Hello, am I audible?
Yes,
Yes,
sir.
Yes, sir. Okay. Okay. Good afternoon, all. I hope screen is
good afternoon, sir.
good afternoon. So, last lecture we have just started introduction of our subject. The subject name is EM. So, those who have not attended last lecture, for them I will take quick review. So, our subject basically most one of the important subject from the syllabus, where a number of calculations, trigonometry, some equations, many more things it will include. Okay, as far as this theoretical part as well as problematic, it is a combination of both. And basically, this subject is related to engineering physics. What you have learned, that base is required for us. So, as we discussed, so EM engineering mechanics. So, a lot of students. So, those who have not attended last lecture due to some network issue, etc., for them we will take quick recap. Okay, so what we have seen. So, as far as mechanics subject is concerned, in last lecture we have seen this subject is basically divided into two types. So section 1 and section 2. Just first slide I have shared here itself. What the contents are there for this section 1 and section 2. So in first section there are total 4 chapters, and in second section there are again 4 chapters. So total there are 8 chapters. Okay. So as far as syllabus is concerned, this contents are more, syllabus is also more, we can say, because 8 chapters are there. Even number of varieties of problems are also there in the syllabus. Okay, so that we have seen. So as I discussed, so let us see in upcoming syllabus. So I feel, or there may be certain students whose this is my first lecture. Maybe one of these their 60 essential case. So I know you was unable to attend last lecture. Maybe something. Those who have not attended last lecture, for you, you should take screenshot in between, or you can write immediately. So those who were absent. So this one is section 1 and section 2, you remember. So number of 8 chapters are there in total in syllabus. Out of that, 4 are there in first section, 4 are there in second section. So list, if meanwhile you can just read a list. So first one is the resultant of coplanar forces. So a little introduction I have given on that. Then still we will go for in further syllabus. Then equilibrium of rigid bodies, analysis of pin joint plane frames, center of gravity and moment of inertia. So first three chapters are related to each other. Fourth is little different. No base is required out of that first three. Then there is kinematics of particle, kinetics of particle, work energy method, and mechanical vibration. Second section and first section. So what I told, first section is famously known as what? Are you remembering? Very good. First section is famously known as statics. Okay, we will see what is statics. And another section, second section is known as
Dynamics.
dynamics. Second section, as we told, it is known as dynamics. Okay. Then resultant. Then let us see further what we have seen. So those who are attending first, this is my first lecture. Those who are attending, attend it carefully. So just we have started with the mechanics. What is mechanics? And we have discussed this also. So for other students, it is just a revision. Okay, so let it be. So mechanics is the branch of physical science which deals with the study of forces and their effect. Okay, it is a branch of physical science which deals with uh, study of forces and their effects acting on a body which is at the rest or in motion. Means, as I told in last lecture, in this subject we are going to study forces, not only forces but their effect on the body. Then condition of the body, it may be at the rest, that means it may be stationary, or it may be in motion, that way. So that's why in statics body is at the rest or it is at the stationary position, and in the other case dynamics it is in motion, that we have seen. So remember, unless so whenever we want to study mechanics, there should be a force. So this term is most important. If there is no force, our subject will not be in existence. As simple as this. So whenever there is a force and its effect on body, we can say it is a mechanics. Are you getting? So which is the most important criteria for our subject to be in existence is force.
For
Study of forces. Study of forces we are going to do in this subject further. Mechanics deals with the study of different laws and principles that we will see which principles, which different laws are there that we will see to solve the engineering problem. Okay, further, it is mainly divided into two categories or two types. This mechanics is classified into mainly two types. One is statics. Those who are attending first time, for them, one is statics and another one is dynamics.
Dynamics.
Those who are present, can anyone tell what does it mean by statics? Let us see what you have understood from last lecture. What is statics? What word we have to remember whenever there is a statics word? What we have to
Body.
remember?
Body is at rest.
At rest.
Body is at rest. It is simple in short. Body is at rest. Body is at rest means it is a branch of, again, it is a branch of mechanics. Branch of engineering mechanics which deals with the study of forces and their effect acting on the body, which is at rest. Most important word. This word is most important. Means in statics we are going to study the body is at rest. Okay, that is statics. And what is dynamics?
body,
Body.
body which is
Body is
motion.
in motion.
What is dynamics? It is the
Body
branch of
Body is in
which
motion.
Body is in
whenever
motion.
body is in motion, whenever there is body is in motion, so we are calling it as a dynamics. For example, such problems are there. Trains. One train is going from the suppose left hand side, another one is passing through right hand side. At what time they will meet, etc. Even one stone is thrown in air, so with certain velocity. At what time it will reach to certain height? Okay, or what will be the maximum height achieved by that stone? Something like that. Or once suppose a stone is dropped from the building, how much time it will take to strike a ground? Such problems are there. Means body is in motion. That is dynamics. Okay, that we are calling it as a dynamics. And in statics, body is at the rest. It is as simple as this. In statics, body is at stationary. In dynamics, body is in motion. Further, dynamics is divided into how many parts?
Two
Further,
parts. Kinetics and kinematics.
kinetics and
And kinematics.
kinematic.
so what is kinetics? It is a sub branch of what? Dynamics or statics?
Dynamics.
Kinetics is the branch of dynamics which deals with the study of forces and their effect acting on a body in motion. Acting on a body in motion by considering the mass. So what is kinetics? By considering the mass and the forces which cause the motion. Forces which cause the motion means this word is important. Here what we are considering in case of kinetics? What we are considering in case of kinetics?
Mass.
Mass and force.
Whose mass we are considering?
Force and mass.
Force and mass. But whose? The mass of the body and force which is cause the motion.
Cause the motion.
Force which is cause of motion or which cause the motion, that we are considering kinetics. On the other hand, we are not considering the force which cause the motion and we are not considering the mass of the body. That branch is known as what? That branch is known as
Kinematics.
that branch is known as kinematics. Okay. So engineering mechanics, it is divided into two parts. One is statics, another one is dynamics. Further, dynamics is divided into two parts. One is kinetics, another one is kinematics, that we have seen last lecture. Then actual syllabus we have started. Actual syllabus we have started, in which we have just seen what it contains in the syllabus. So we should know. Once some part we are going to see, so we should know it is a part of our syllabus. That's why one of the slide I have introduced here. So what will be the syllabus? Okay, and the chapter name, resultant of coplanar forces. That we will see. Resultant. What does it mean by resultant? That also we have discussed. That also we will see. So chapter number 1 from engineering mechanics subject from the engineering mechanics subject is resultant of coplanar forces. It is very interesting chapter. Only your geometrical knowledge, or we can say trigonometrical knowledge, calculation knowledge, that should be good, so that whenever angles we are necessary to find, okay, so your geometrical knowledge is important. On the other hand, some trigonometrical formulas we have to apply to find certain angles, certain distances. Okay, so once actual problems will start, you will come to know that how it is interesting. One of this chapter is the resultant of coplanar forces. Okay, so this one is the syllabus. Already we have read in last lecture. So just those who are new for this lecture, they can just take screenshot. Afterwards, you can write in your notebook. Okay, so resultant of coplanar forces. This one is the syllabus. Basically, basic units. SI units: body, rigid body, particle, scalar quantities, vector quantities, ideation of engineering problems, force, law of transmissibility of force, most important. What is the law of transmissibility of force? We will see. Moment of force, couple, moment of couple, resultant, parallelogram law of forces, triangle law of forces, polygon law of forces, Varignon theorem, most important one. Then composition of coplanar concurrent and non-concurrent forces, analytical method, graphical and Bose notation. So these many syllabus is there. It is very interesting. Once it will start, actually you will come to know that. Okay, next one, resultant of coplanar forces. So as we discussed, force, what does it mean by force? Those who were present for last lecture, they can tell what is force. I have told
External agent
Changes the
which
state of
changes
the
the
body.
state of body.
external agency which changes the state of body means what? Which state of body? Solid, liquid, gas, what? Which state of body? From chemistry, that state you want to know, or something other test state? State of body, which state?
Body which is at motion or at rest.
Or rest.
Very good. Body. So here we are not going to consider the state from the your engineering chemistry, something like that. Okay, here which state we are going to consider? Either it is in motion or is it at stationary or rest. If it is in stationary, the thing which will make it in motion, it is called a force. Or what we can say, if a particular thing is in motion, once we are going to make it stationary or rest, that is called as force. Example, can anybody give example of force? Anything? Huh? Example of force, because without force our mechanics is not there. Force, can anybody give example? Last lecture I have not asked any example of force. Applying the brake for a vehicle, is it force?
Yes, sir.
Whether it will be force?
Yes, sir.
Applying a brake to vehicle, to a four-wheeler, whatever. Applying a brake is a simple type of force. So which motion is converted into which motion? The vehicle is in motion. So we can make it stationary or rest by applying the force, that is brake. Once we are going to apply the brake, many more practical examples are possible, you can see. Further, coplanar forces means, so what is coplanar forces? That also we have discussed. Coplanar forces, what is coplanar forces? So whenever
Lines
force,
lies in four.
only we cannot say line. So whenever there is force, so
Force
you
and a
remember this word,
system of force.
Line
LOF,
of action.
line of
Line of action lies in a
Single plane.
single plane.
very good. Line of action of force lies in single plane. What is the
Single.
example of plane? Example of plane. एखादं plane म्हणजे काय असतं सांगा बरं. I have given example in last lecture. What is plane? So for that I went to little in geometry. What is point? What is line? What is plane? What is solid, etc. So plane means what? Plane. In last lecture I have given example of this. It is having how many dimensions? Only
2 dimensions.
2 dimension page. because as compared to its two dimension, its third dimension is negligible. Its third dimension is negligible. That's why it is called as plane. Means all the line of action of force, if it is lying in single plane, then it is called which type of forces? Then it is called which type of forces?
Coplanar.
Coplanar. You
Coplanar.
remember this?
Coplanar.
Coplanar. Our mechanics subject is related to this only. Coplanar. Our mechanics subject is related to this force only. Coplanar. We are not interested in other forces. Non-coplanar. If you will take example of non-coplanar, no, it is very wide area, we can say. It is very wide area. So our subject is related to coplanar. Coplanar means what? I have given example even. If there is one page, and if you draw a number of lines on this a page, particular page, number of lines, okay, then all the lines will indicate plane, and that all lines will be in one plane. That's why it will indicate which type of forces. Which type of forces? Any force is going out of this page. The lines drawn on pages, which type of forces it will indicate?
Coplanar forces.
It is as simple as this, coplanar forces. It is coplanar forces. Okay. Next one is we have seen resultant. Resultant is a force which replaces number of forces having same effect as that of original force. What is the resultant? What is the resultant? So example, are you remembering which example I have given last lecture? So I have considered one body A. Okay, from this side, how much force I have applied? I think 5,
5
no?
kilonewton.
5 kilonewton.
Okay, and from this side,
10
10
kilonewton.
kilonewton.
10. So two forces are applied on body, and if I will replace these two forces by single force, whose effect is again same, suppose something like this A. So it will be something like this. Okay, so what it is called? So what this is called 5 kilonewton?
Resultant.
Resultant force.
Resultant means in a system of
Resultant force.
forces. In a system of forces, there may be a number of forces which are acting on the body. So we can replace all the forces by single force. What will be the criteria to replace number of forces by single force? काय criteria असू शकतो? Number of forces you want to replace by single force. What should be the criteria? The criteria काय असला पाहिजे? As far as its effect is concerned, what should be the criteria? What should be the criteria? I have made a box here. What should be the criteria? Number of forces if I want to replace by a single force. That single force, how it should have effect?
Same effect.
As far as it should have,
Same effect.
it should have same effect as far as number of forces are
Number of
concerned.
forces.
Is whatever it may be the effect of number of forces, whatever it may be the effect of number of forces, it should be the same as the resultant. Or resultant should have same effect. Then only we can replace that force by resultant. Otherwise, not. Okay, resultant. Which word I have told, or which thing is opposite to resultant? It is not on the screen. Let us see your knowledge.
Resolution.
Resolution, very good. Resolution. Those who are remembering, it's a good thing. Resolution. So resultant means what? Representation of number of forces, or converting number of forces into single force. Resultant. And what is resolution? What is resolution?
A single force converted into number of force.
Number of force. Single force is converted into number of force. Instead of number of force, we can convert into two components that we will see. Not number of component. If there is one force, so we can convert that one force into its two component. कुठलाही एखादा फोर्स असेल तर तो त्याच्या दोन कंपोनेंट मध्ये कन्वर्ट करता येते. इट इज कॉल्ड एज रिझोल्यूशन.
Resolution.
That we will see. After that, that we have seen. A central idea. Quickly, we will see what we have seen is what we are going to see. Basic terminology, different laws, resultant of force, how to calculate resultant because that is the name, resultant of coplanar forces. Then moment, different types of forces that we will see in this. So one terminology we have seen related to forces. Coplanar forces already we have discussed what is coplanar. After that, concurrent and non-concurrent. Anybody is remembering concurrent forces?
All forces pass through a common point.
All forces. Instead of all forces, whenever we want to show force, so we have to use word line of action of force. That is a very important. Line of action of forces will pass through single point. Why this word is important? Line of action of force. So here I will give example. Okay. Suppose there is a rectangular block called ABCD. ABCD. At point A, a force of suppose 10 kilonewton is applied towards right hand side. Okay. And there is another block, very important to understand the concept of line of action. A, again same block we can say, or similar, same block A, B, C, D. And at point D, in this way, at point D, a force is applied of again suppose 10 kilonewton. Okay. Are you getting? So there is block and we are observing from the front of that block ABCD. At point A, 10 kilonewton force towards right hand side is applied. On the other hand, there is same block of ABCD and at the corner D. At corner D, again force of 10 kilonewton is applied towards right hand side. Now, remember these two conditions and you tell me whether in both cases, uh, whether both cases are same or different. Whatever cases are there in front of you. What do you feel? Whether that forces will have same effect in both cases or it will have some different effect. Huh? Am I audible?
Yes.
Or you are thinking? You are thinking. What is your opinion as far as this is concerned?
Maybe same.
Not maybe. Either this side or this side. Maybe means partially. What is your opinion? Whether that effect of 10 kilonewton force will remain same in both cases or it will be different?
Same.
Same. Same. On which basis you are saying it will remain same?
Same. Mm,
Same.
Because
So okay, tell who is telling? Let me know. Okay, explain. Who is explaining? Somebody want to tell something. Who said because? Okay, no issue. Be responsive. You can give a response. No issue. Somebody want to give an explanation. Effect will remain same. I will give answer. Effect will remain same. Now tell me how. So effect will remain same in both cases, irrespective of application of point. Effect will remain same. फोर्स आपण ए च्या ठिकाणी लावला इकडे डी च्या ठिकाणी लावला इफेक्ट विल रिमेन सेम. Now as far as force is concerned, there is one law. It is called as law of transmissibility of force. Law of transmissibility of force, that also we are going to see in depth in further syllabus. Which transmissibility of force means what? Suppose there is force something like this. So this force you can extend up to on that line, transfer we can say, either this or this side. This force you can transfer on that line, whatever that line will pass through D. That's why whatever line, horizontal line is there, that 10 kilonewton force you can show anywhere on that horizontal line, line AD. Here also you can show. Suppose I will show this both the diagram again combining here. I can show same something like this. Okay, here A, B, C, D. Here also I can show effect will remain same 10 kilonewton in this way. It is called as law of transmissibility of force. काय म्हणायचं याला law of transmissibility of force. It is there in further syllabus. But meanwhile, whatever line of action, line समजते सगळ्यांना आता, line of action of force on that line you can show anywhere. Effect will remain unchanged. It is called as law of कुठला लॉ म्हणायचा याला फोर्सचा कुठला लॉ आहे हा
Transmissibility.
लॉ ऑफ ट्रान्समिसिबिलिटी ऑफ फोर्स काय म्हणतो हा लॉ ऑफ ट्रान्समिसिबिलिटी ऑफ फोर्स whatever line of action of force is there you can show anywhere on that line of action of force that effect of force will remain unchanged. एखादी जर लाईन असेल लाईन ऑफ ऍक्शन ऑफ फोर्स त्याच्यावरती तुम्ही फोर्स कुठेही दाखवा इफेक्ट चेंज होत नाही. इट इज कॉल्ड एज लॉ ऑफ ट्रान्समिसिबिलिटी ऑफ फोर्स. In further syllabus we will see that law. So you can see here, so either you can show the at point A or at point D because that force is going to be horizontal through side AD मधून ते पास होणार आहे. That's why it will remain same or unchanged. That's why it is called as law of transmissibility of force. आपण कुणीकडून कुठे गेलो होतो concurrent forces and non-concurrent forces means what? From there we went to there. What is concurrent forces? Shall I erase this? What is concurrent forces? Concurrent forces
Line of action of forces are at single point.
are passing through single point. असं बोलूया आपण. Passing. Line of action of forces are passing through single point. Okay, on the other hand, what is happening in non-concurrent forces? This is most important for multiple choice question. In non-concurrent forces, what is happening? Line of action of force. This is most important. Line of action. So this much is line.
Line
If
of action
you
of
can-
force are not passing
Line
through
of
single
action
point.
of-
Very good. Are not passing from single point. It is called as non-concurrent. In mathematics, this word is familiar. Concurrent and non-concurrent. Okay, that you can see. Okay, concurrent circles you might have drawn in geometry. Whose center is same? Whose center is same, but we can say circles are having some different radius in that way. Similarly, concurrent and non-concurrent. Concurrent forces in some cases, इथं असे होऊ शकते एखादा फोर्स इकडून येतोय असा another is passing from suppose something like this. Okay, and another is maybe from this horizontal or something like this. I will draw. Okay, असे तीन forces I suppose. I will say it as F1. I will say it as F2, and this is F3. Okay, force. So whether these three forces are concurrent,
Yes, sir.
Yes, sir.
concurrent. But by visualization, you may say it is not concurrent. But once you are going to extend this line of action of force, त्या लाईन वरती तुम्ही कुठेही दाखवा या व्हर्टिकल लाईन वरती कुठेही F1 दाखवू शकता. F1. Either you can show here F1, either you can show here F1. No issue. Effect will remain same. Most important concept of mechanics. On that line, you can show anywhere F1. Similarly, this. Okay, in this way, suppose. Okay, F2 in this way. F3, no, this is F3, and this one is maybe something like this. F2. This is F2. This one is F here. So all three forces, if it is passing through single point, if all these three forces are passing through single point, it is called as which type of forces? Which type of forces? Concurrent forces.
Concurrent.
If it is not passing, it is called as non-concurrent. That is also non-concurrent. You remember those who were absent for last, take the screenshot. Concurrent and non-concurrent. Further. So this one is example actually in 3D, which is not important. Importance of chapter. We have discussed but we should study this chapter. to find out the resultant and further resolution of forces. This one is also we have seen chapter outcomes. Means at the end of chapter, what we should know. Chapter is very interesting. First part is something theoretical part. Once actual problems will start, you will enjoy this chapter. I'm sure. So, student will understand fundamental concept of statics. We will discuss already with some of the concepts I have told. Then students will be able to apply different laws. Student will understand the concept of finding the resultant. Engineering mechanics, same is there. Mechanics means what? Forces and their effects. Then engineering mechanics divided into two parts. One is static, another one is dynamics, kinetics. Further, dynamics is divided into kinetics and kinematics. So just now we have discussed. I think we came up to here, no?
Yes, sir.
Mechanics. So this chart I have told. We came up to this mechanics and mechanics of rigid body. So what we are going to study? Mechanics of rigid body. So you might be remembering. So the different types of body we will see. So this further syllabus is there for the civil engineering and mechanical engineering in your higher classes. So this mechanics of fluid, mechanics of deformable body, that we will see. So some of the practical examples of mechanics. Anybody? So truss bridge. मी काल एक एक्झाम्पल सांगितलं होतं बघा स्टॅटिक्स body rest over us, then different forces are applying. So anybody is there able to tell some examples? Statics. So some examples we can say. Some statics means what? Statics we are studying forces and their effect on the body. But how should be the body?
At
Rest.
It should be at rest. No, it should be at the rest. Any example?
Car resting on
Yes.
bridge.
Car resting on a bridge. Okay, that resting is most important. Otherwise, if it is passing on the bridge, then that load will not be remain constant. It will vary. So it will go into your dynamics. What is this second figure? What is this figure?
Engine.
Engine.
Engine. Actually, it is a part of engine. It is not total engine. Out of that engine, it is called as piston and cylinder. Have you heard this word? Have you heard the word piston?
Yes. Yes, sir.
Sir.
It is piston and cylinder of the engine. It is a part of engine. It is not engine, actually. It is a part of engine. So this one is piston. It one is piston. This one is crank, etc. So whenever we are starting a vehicle, this piston arrangement, this is to and fro arrangement is going on always. This one is to and fro arrangement, up and down. So this arrangement is up and down. So it will take load, etc. Always. So this one is the example of dynamics. So it deals with the forces and its effects when the body is in a moving condition. Body is in moving condition. It is dynamics. On the other hand, bridge. One more example I have given yesterday. As far as this bridge, some structure is provided in electrical pole, etc. Whether you are remembering this, maybe something like this pole where the structure is provided, something like this. Maybe here, something. Okay, maybe here that pole near lines are passing, something like this. Okay, so some lines you might be observed. So this structure is provided. What was the reason to provide such structure? काय reason असते the structure provide करणे? What is the reason to provide this? Is it for aesthetic purpose to have a beautification, or any other reason is there for the electrical pole in which some parts are provided in inclined fashion? What was the reason of that? To transfer force. If only one element is used, which is vertical, what will happen? If only one element is used, what will happen? It will get break, no? Due to heavy load. So that's why number of elements are used. Okay, so different examples are there. Then basic concepts. What is body? Some definitions we will see here in this. Some definitions. So am I audible? Try to say yes, no.
Yes.
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Basic concepts. So in that body, what is body? What is body?
Body has a
Having mass and definite shape.
Definite mass.
Definite
Big
mass
mass.
and occupied is defined.
Means in each subject there is certain basic structure.
सर आवाज येत नाहीये.
Sir, your voice is not audible.
No, sir.
Just check. Is it audible?
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Okay. Body. So have you heard this word system and surrounding?
yes, sir.
Have you heard?
Yes,
So
sir.
where you have heard this?
Yes, sir.
in 12th.
It's probably in thermodynamics. What is the definition? So have you heard these words in thermodynamics?
Yes, sir.
Yes, sir.
Okay, so what is surrounding and system as far as thermodynamics is concerned? So the part of universe which is under consideration is system. Whether such definition was there or some other definition was there? Yes. Whether it was the definition?
No, some other.
Which was that then? Then what was the definition? That system and surrounding? Okay, further, as far as that is concerned, thermodynamics, the part of universe which is under consideration is called the system. So forget about it. We are not considering that. Body means what? Body means what? An object which has definite mass and which occupies the definite space is called as body, as far as our subject is concerned. Okay, as far as our subject is concerned. Thereafter, rigid body. Second step, now this you have to write in your notebook. This is the core part of our syllabus. Body, either you can take screenshot or you can write in your notebook. Okay. Body, an object which has definite mass, which occupies the definite space is called a body. It is a such object. Then types of body: rigid body, elastic body, and which one another I have told yesterday?
Plastic body.
Plastic body.
Plastic body. One is rigid body, another one is elastic body,
Elastic
and
body.
another one more is called the plastic body. What is rigid body? We have discussed a body which does not undergo any change in its dimension or shape after application of external force is called as rigid body. It's called as rigid body. So whether such rigid body is available, is it there in existence? Rigid body. Whether such body will be in the existence. Whether such body will be in the existence. Ideal, such body is ideal, we can say. It will not be in existence. Okay, because irrespective of its rigidity, once we are going to apply the force, it may undergo some or the other deformation. That's why rigid body is practically not possible. It is ideal body, rigid body. What is elastic body? What is elastic body?
regain its original dimension.
When it will regain its original dimension or shape? When there is a removal of
After
external,
removal of external force.
after, after removal of external applied force. A body that regains its original dimensions after removal of external applied force is called an elastic body. Here you can write one more, plastic body. So actually it is not there. So here you can write one of their something like this. Maybe other, it is not mentioned here, but as for our information, you can write here. Plastic body. What is plastic body? We have seen yesterday.
Body get permanently deformed and cannot regain its shape.
Body gets permanent deformed and it will not get its shape and size.
Original
Example we
shape
have seen
and size.
yesterday. Example
Mud.
what we have seen yesterday.
Mud.
Rubber.
Mud is the best example of it. Okay, then that motion of rigid body we will see afterward. Then displacement. Now these terms are familiar to you. These terms are familiar to you. Displacement. What is displacement? The distance moved by body. What is difference between displacement and distance? It is there. Okay, displacement means what? Displacement means what? The distance moved by a body or a particle in a specific direction is called the displacement. Okay. On the other hand, velocity. What is velocity?
The rate of
Rate
change
of
of
change of
displacement
displacement
is called velocity.
with respect to time.
The rate of change of displacement with respect to time is known as velocity. What is acceleration? These terms are mere, we can say, revision. Already you know these terms. Acceleration, the rate of change of what now? dv by dt. Rate of change of
Velocity.
the rate of change of velocity with respect to time is called the acceleration. Okay, then what is distance? The numerical description of how far the object is located. It is defined as the length between length of specific path traveled between 2 points.
Between two.
Okay, so what will be the difference between displacement and distance? Displacement and distance.
Displacement have direction. Displacement is a vector quantity and distance is a scalar quantity. Sir.
Displacement is a vector quantity and distance is a scalar quantity.
Very good. Displacement is a vector quantity, distance is a scalar quantity. Very good, as you know better. Next one is speed. Again, the rate of change of this. Are you writing or are you taking screenshot? Shall I give some time to write because it
No,
my
sir.
speed? What is your
Screenshot.
but that it should not remain in only in your mobile. Huh? It should come on your come in your notebook. Huh? That care you have to take. Otherwise, I will give certain time to write. What is your practice? What you are doing?
Taking screenshots. Sir.
So
Screenshot.
try to write. Huh?
Screenshot.
So okay, no issue. You should write it in your notebook. After once problems are going to start, at that time we will solve it together. There is no question. But right now, as it is a theory part, I am taking little, and as you know better, this terminology. So try to write in your notebook. Huh? Otherwise, at the end, it should not happen that screenshots are remaining in only mobile and it is not in your notebook. It should not happen. Huh? Take care of that. Speed. The rate of change of distance with respect to time is called the speed. Okay, the rate of change of distance with respect to time is called the speed. Speed is what? Scalar or vector quantity?
Scalar.
Scalar. And velocity is?
Vector.
Velocity is vector, as you know better. Momentum. What is momentum?
Product of mass and
Product of
velocity.
mass and velocity.
Into velocity.
The product of mass and velocity is momentum. I will ask here one more question. What is moment? Have you heard this word or this term? Instead of word, I will say term. Have you heard this word term moment? Whether these are same or different?
Different.
Yes. Whether these are same or different?
Different.
Different. Then what is moment? What is moment then?
क्षण क्षण मराठीमध्ये क्षण
No. That is different. As far as mechanics is concerned, that moment we can say that is different. But this moment, you remember. Meanwhile, we will see in further syllabus. Moment means rotational effect. Moment means rotational effect. आता तुम्ही जो क्षण हा सांगितला तो झाला प्युअर प्रॅक्टिकल वर्ड रोटेशनल इफेक्ट. सो इट इज कॉल्ड रोटेशनल इफेक्ट. दॅट इज कॉल्ड मोमेंट. फिरणे थोडक्यात. सो अगदी शॉर्ट मध्ये व्हॉट इज मोमेंट इफ यू वॉन्ट टू से इट इज अ रोटेशनल इफेक्ट. फिरणे म्हणजे आपण एखादी चावी फिरवतो समथिंग लाईक टॅप ऑफ आवर वॉटर टॅप. once you are going to rotate आपण फिरवतो. It is example of actually couple. Two equal and opposite forces will form a couple. That also we will see, don't worry. But this meanwhile moment means rotational effect. And what is momentum? The product of mass and velocity is known as momentum. So there is a little confusion between these two terms. Okay, momentum and moment. Moment means rotational effect. It is something related to rotations. Okay, or rotational. It is called moment. That also will come to know. And that moment, whatever somebody has told, it is totally different. Kshan. Some we can say what in other words. That is totally different. Okay, moment means in our mechanics rotational effect. You remember this. Then scalar quantity and vector quantity. You know better. Can anybody explain this scalar quantity and vector quantity? Scalar quantity,
Scalar
quantity
only has magnitude.
which has only magnitude, or it can be described only by the magnitude. It can be described only by the magnitude. And what is vector quantity?
Vector quantity have
Magnitude as well as
magnitude and
direction.
Have magnitude and direction, both direction and magnitude.
Both it should have a magnitude and direction. Okay, so examples are there. So first, length, mass, time, area, temperature are the examples of scalar quantity, and others are the examples of vector quantity. Okay, please note down this. Okay, it should be there in your notebook. Okay, so the scalar quantity, vector quantity, very simple multiple choice question may be asked. Which of the following is scalar quantity? Which of the following is the vector quantity? Or certain term is given. Momentum. Momentum is a scalar quantity, vector quantity, quantity, etc. So momentum is what?
Vector quantity.
Momentum is
Vector.
vector. Force is
vector.
displacement is
Vector.
velocity.
Vector.
Velocity is also vector. Mass is
Scalar.
area is distance is
Scalar.
distance is also a scalar quantity. Distance is also scalar quantity. Okay, so please note down this. Please stick so that you can write in your notebook. Further, a force. So what is force? So as we discussed, the force is nothing but a physical entity who will change the state of body. If body is in rest, it will make it take into motion, or if it is in motion, it will take into rest. Okay, so a simple example is given. Some car is lifted with the help of some rope by applying certain force. Even once we are going to see rail track and railways passing on the railway track, every wheel of that it is applying the force. So certain things are related. As far as force is concerned, few things we have to remember. Which are they? Point of application, most important. Where force is applied, application, where it is applied, point of application, direction, in which direction it is applied, and what is its magnitude. What is its magnitude? Okay, so these 3 points, even in some cases line of action of force is also important. In which direction force is applied, that one is also included in the features of force. So which are the features of force? Means to understand the force completely, which things are important or which things are necessary, it is called as features of force. काय म्हटलं मी फीचर्स म्हणजे काय, की एखादा फोर्स आपल्याला कम्प्लिटली समजण्यासाठी कुठल्या गोष्टी आवश्यक आहेत, इट इज कॉल्ड एज फीचर्स ऑफ फोर्स. पॉइंट ऑफ ऍप्लिकेशन आपल्याला माहित पाहिजे, कुठं फोर्स लावला, इन विच डायरेक्शन इट इज अप्लाइड, दॅट इज ऑल्सो इम्पॉर्टंट, अँड हाऊ मच इट्स मॅग्निट्यूड, दॅट इज ऑल्सो इम्पॉर्टंट. ओके, what is the need to know a mechanics? एखादं मेकॅनिक्स माहित असण्यासाठी, why here conclusion is written. Conclusion, here is a diagram दिसते तुम्हाला. There is one car passing on the road. Are you able to see that diagram?
Yes.
Yes, sir.
Here there is a, here in first diagram, here it is in first case, what we see, there is only one car which is passing, but as far as its mechanics is concerned, इकडे आपल्याला त्या कारचं मेकॅनिक्स दाखवलेलं आहे की किती फोर्सेस असतात, हाऊ मेनी फोर्सेस आर देअर. आपल्याला पहिल्या डायग्राम मध्ये जी इथं जी काय पहिली डायग्राम दिसते, जस्ट वी आर ऑब्झर्विंग देर इज वन कार पासिंग ऑन द रोड. ओके, बट as far as once we will see this car from the point of view of mechanics, so you will see its total weight will be applied in which direction, upward or direction. Here W,
Downward direction.
its weight will be in downward direction, W. Certain force will be applied, suppose what we can say, opposition force of air pressure, something, it will have certain hurdles while going forward, that force will be in opposite direction. That car engine will give the force in which direction, forward or backward, it is shown by yellow color, in forward direction. Forward direction. And once that suppose car is at stationary, okay, stationary, so that reactions will happen. Reactions are always opposite to applied force. So this total weight is in downward direction, the reactions will be there at the end of the tires or wheels. It will be in which direction? It is shown by blue color, upward direction. Upward direction. And once car will start the moving, once the cars will start the moving, there will be the frictional force. There is a friction, that's why we are able to walk on the ground or road. That you might be knowing friction. That frictional force will be in backward direction. Here it is at the end of tires. That frictional force at the end of tires, that will be the frictional force. Means what? What is the conclusion of this diagram? It is just given for the overall information. Whenever there is a mechanics, there is a force. जर आपल्याला मेकॅनिक्स हा सब्जेक्ट स्टडी करायचा असेल तर काय पाहिजे हो? What we need? Force. Without force, mechanics will not be in existence. Okay, so this is important. आपण पहिल्या पिक्चर मध्ये फक्त कार चाललेली दिसते रोड वरून, पण त्याच्यामध्ये किती फोर्स आहेत, नंबर ऑफ फोर्सेस विल कम इन टू पिक्चर, इट इज शोन. And to study this mechanics subject, we need a force. आणि एखादा फोर्स जर आपल्याला समजायचा असेल तर काय काय इम्पॉर्टंट आहे, which things are important to understand force? Just before I have told, एखादा फोर्स समजायचा असेल तर काय काय इम्पॉर्टंट आहे असं मी सांगितलं.
Point of application, magnitude.
Very good. हा, point of application, magnitude. Very good. Again,
Direction.
direction. Assume. Very good. Here it is there. Point of application, direction, and magnitude. Such things are important to study any force. Okay, so it is there. Further types of forces are there in that we will see. we have seen concurrent forces. One more type is there. It is called as collinear forces. Collinear forces. Collinear forces. Have you seen this activity? The activity paहिले कुठं? Or what is the name of this activity? You might have seen in your what we can say high school life, etc. Rassikets. What it is called in Marathi? In English. In Marathi, it is called Rassikets. In English,
Tug of war.
very good. Tug of war. It is called tug of war. So when line of action of all the forces is same, it is called as collinear forces. When line of action of force is called as is in one line only, then it is called as collinear forces. म्हणजे सगळेजण जे ही दोरी वळतात त्याचा जो काय फोर्स अप्लाय केलेला आहे तो सगळ्यांचा एकाच लाईन मधून पास होईल का? वेदर इट विल पास थ्रू सिंगल लाईन? Definitely. That's why it is called as collinear forces. And if it is not passing, म्हणजे ट्रायपॉड माहित असेल तुम्हाला, ट्रायपॉड ज्याच्यावरती कॅमेरा फिक्स केलेला असतो, की हे जे काही फोर्सेस असतात, neither it is coplanar, neither it is collinear, but these are concurrent and non-coplanar. That we will see. Concurrent and non-coplanar. That we will see in next lecture. Okay. Shall we stop for today? Maybe. So write your numbers in chat box so that I will take attendance. Remaining part we will see in this next lecture.